Okay, here we are. This is Mr. Darcy, and we are live and in person, room 263 in Abu Dhabi on 3rd Avenue. Is that right? 3rd Avenue, Khalifa A. Is that right? 3rd Avenue, we're 3rd Avenue? Is that right? 3rd Street? Okay. Now, take some notes, stop, pause, do some of the problems. Don't just sit there and listen to this like it's, Star Wars 7. You got to actually be active. You got to actually be active. Actually be active. ABA. Actually be active when you're doing some of these problems. Okay. Right. A rocket is fired straight up at 100 meters per second. I want to solve for A through F. A through F. Okay, that's going to be the trajectory. It's going to go up and then it's going to be go down. Now, that drawing is not drawn to scale relative to distances. It might be in terms of time, 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, etc. But it's not drawn to scale in terms of changes in distance. Clear? Yes? And we'll look at that in a minute. In a few slides we'll look at that. So I want to solve for, now I'm slowly putting in some scales, an actual graph. So what we can do is we can talk about the problem as it's being set up. So it's going to take a certain time for this rocket to reach the top. I'm going to ask my class, how long is it going to take to reach D max? Anybody? 10 what? 10 seconds. Very good. Very good. Very good. So it'll reach 10, so it'll do it in 10 seconds. Okay, so I'm actually kind of giving the answer away by slowly building the graph. Is this a little boring? It's pretty good? Pretty cool? Okay. So, it's Flag Day. Is that correct? Flag Day. Happy Flag Day. Right? I got my pin, my UAE pin. Yes, is that cool? Excellent. All right. It's Flag Day. Happy Flag Day to all UAE. Okay, what's the capital of the United Arab Emirates? Anybody know? Abu Dhabi. Excellent. What's the capital of Burkina Faso? Burkina Faso. That's in West Africa. Starts with a D. No, starts with an O. Oh. No, that's wrong. Oh, we have somebody from Ethiopia, actually due east of Burkina Faso. What's the capital of Burkina Faso? Do you know? What is it? Blah. What is it? Ouagadougou? Close, believe it or not. Ouagadougou. That's actually pronounced correctly. All right, so we see that the answer is 10 seconds because you have the equation VF equals V naught plus G delta T. G is negative. F is final, so that's going to be 0. So you divide through and you get T equals 10 seconds. There you go. Easy? Pretty cool? Okay. So then what you want to do, I think we should actually stop this and keep what we've done and maybe change the speed of the slides. Shall we do more national capitals of Africa? Okay. What is the capital of Djibouti? Djibouti City, or just Djibouti. Djibouti was a colony of what country? No? France, I believe. Isn't that correct? France? Wasn't it French? Wasn't it French? I think it was French. Yeah? I think it was French. All right, now we're doing max D. Max dy. Why does it say dy? Rauda, why does it say dy? Rauda, I caught her giggling. She's giggling. Okay, Rauda, why is it dy? She doesn't know, but she thinks it's very funny. I like that. She's a very happy person. Excellent. Rauda, any idea why it's a y? Why? Because it's the y-axis. Y-axis is given to be vertical. X is horizontal. So we say dy sometimes. And to find dy, that's it. It's going to be 500 meters because it's going to be d equals 100 meters per second times 10 seconds, and then plus 1/2, and then negative 10 meters per second times 10 seconds. Why times 10 seconds again? It's 10 seconds is the total time of the flight. correct, to the top. Yes? So it's 500 meters. Make sure you square that, right? So it's going to be it's going to be V naught T plus 1/2 GT squared. So it's 500 meters, correct? So now we're going to be talking about something else. Let's give Rauda an actual problem. Rauda, what is the capital of Oman? Oman. What's the capital of Oman? Muscat. Rauda didn't know that. She did not know that the capital of Oman is Muscat. Now everyone in the world knows that, okay? All right, let's give, you want another one or you don't want another one? You want to try to redeem yourself? You don't want one? Okay, no, she's okay. Okay, that's cool. What about gutter? How do you say it? Gutter. You say gutter, 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 gutter. What's the capital of gutter? Doha, very good. Okay, so now we're going to find what is the velocity at max D. That's kind of a trick question, only if you get it wrong. What's the velocity at D max always?
0.
And how did you know that? It says it on the board. Excellent. So you didn't figure it out, in other words?
No, very smart.
But you're too smart for that?
Yeah.
Excellent, excellent. Let me introduce you to Mohammed. Mohammed is actually from Bahrain.
No.
No? I thought he was from Bahrain. You're not from Bahrain? He's local, but I thought you were originally from Bahrain.
Yeah.
Originally. So he is, yes, but he was just trying to, say no, because he wanted to sound like Mr. Darcy. Okay, so what's the capital of Bahrain? He forgot.
I'm not from there.
What is it? Manama, that's correct, Manama. Okay, so the velocity at D max is going to be 0, and that's always. Now the next question, we're going to do a sneak peek, okay? All right, we're going to leave this one for Amir. Amir has been late a few times. Now I have it on record. I want Mr. Amir's father to know that he was late today. He said he was out carousing all night and he didn't go home to sleep, and he just came in to school without going home and out showering. And is that true, Amir? No, that's true? Excellent. Well, we found out now. Okay, what is the gravity at dy? I should say, got an incoming message. I should say dy max, but I don't say dy max, but I should say dy max. 10, yeah, it's always 10. There's only really two choices. It's plus 10 or minus 10. Now, if it's right stopped, it's just 10. It's neither plus nor minus, it's just 10. But it's always that, like, what's the acceleration due to gravity right now on you? Right now? 10, yeah. Why? How do you know that? Do you feel the weight on your chair? That weight is a result of the gravity working on your mass. So you know it's 10 because that 10 is a result of, that weight is a result of 10 times your mass, and then that's the downward force, and then the upward force is called the normal force. If you didn't have the normal force, you would appear weightless even though you wouldn't be weightless. You'd appear weightless because you didn't have the upward force. And we'll talk about that more when we do Newton's laws, okay? So the answer to that question, it's only a trick question if you get it wrong. If you get it right, it's not a trick question. You ever wonder about that? Why is it a trick question only when you get it wrong? Have you ever said a tricky question was tricky if you got it right? No, you didn't. Route is like tricky.
Like to look, make you look like you're smart.
To make it look like you're smart. In other words, you may not be because you got lucky. Okay, excellent. That's not a trick question. That's just being lucky. Okay. So the answer is 10 meters per second squared. Okay, now, the next two are going to be a little bit more difficult, and they're going to be similar to ones we've already done on worksheet 16R, which is lecture 3. And that is, what's the velocity at t equals 18 seconds? Anybody know? Draw a graph. It goes up 10, goes down 10. That's 20 for the entire trip. So if it's 18, is it rising or falling at 18? It's falling for how many seconds? 8 from rest. So what's the velocity? 80 meters per second. It's right there. You see that? Cool or what? Now answer me a question for the folks at home. Okay, I feel like I'm on like the Mr. Darcy show, and this is kind of like we should have guest stars. If it was that guy's name, John Stearns. What's his name? Stearns, long hair, weird guy. Used to be on American radio. Something. Anyway. whatever, I don't know what it is. Anyway, negative 80, right? Negative 80 meters per second. Okay? So now the next one, what do you think the next one's going to be? The next problem? Brad, stop enjoying yourself. Stop smiling. Okay? You can't smile anymore until January. You've hit the smiling index for a class. Okay? So what is the next one going to be? What's the height off the ground, right? Right? At t equals 18, so it's 2 seconds from the ground, what's the height going to be? Okay? Oh, this is just a little on the side. That negative sign is assigned because it's going down. Yeah. So what we do in here, listen carefully. Up gravity is negative. Down gravity is positive. Up velocity is plus, down velocity is minus. Now, there's going to be books that are going to be contrary to that, but it makes no sense. So we're just going to use that as a Mr. Darcy, room 263 rule of thumb. Clear? Yes? Okay, so how do you find the distance, the dy at 18 seconds? How would you find that? Well, you would find it, shall I help you? V naught t plus 1/2 gt squared. So what is V naught? No, it's not 0. At 18 seconds, what is it? What's V naught? 80 meters per second, right? What's the time? 2 seconds, right?
Yeah.
You're 2 seconds from the bottom.
Yeah.
Plus 1/2 is g positive or negative? Positive because it's going down. And then t squared, what's t? 2 seconds from the bottom. So if you do that out, you're 180 meters from the bottom. You see that? Are we cool or what? Are we very cool? What's the guy's name? I can't believe I don't know this guy's name. Alan Stearns, Thomas Stearns, something. I can't believe I can't remember. Anyway, see how being away from America makes you forget certain things? You know, do you ever do that? Certain things that you don't remember from home? Okay, now this is just to show you how the other graph was not drawn to scale, but this graph is drawn to scale relative to distances. You see that? See that? If I made a distance time graph, it would be curved at the top. So the distance is there. And I'm going to show you this. This we're going to actually stop right now. At the next slide, we're going to stop. And I'm going to speed this up because it's annoying. So in other words, this looks at the velocity change. What do you think that 1 second the velocity is going to be? At 1 second, what's the velocity going to be? Well, if it's going to decelerate at a rate of 10 meters per second squared, it would be 90, right? What would 2 seconds be? 80. And what would the top be? And what would the speed be at 19 seconds? Minus 90. Do you see that? Do you see how this goes? So what we're going to do is we're going to stop this, and I'm going to change the time for each slide to 1 second. Now let's say 2 seconds. Let's go crazy. Okay, so we're going to stop this, save it, and all right, 2 seconds a slide. Here we go. 70 plus 70 plus 60 plus 50. What's next? Plus 40. What's next? Plus 30 plus 20 plus 10. 0. 0. Okay, so you get the point. You get the point. Amir, are you with me? Excellent. And now this is going to slow down again. Now we're at minus 100. And then we're going to do another one, very similar, but I want to make it long, so the first one long, so I can set everything up for you. Yes? And you'll see how things will change. So I'm going to pause after this slide, and I'm going to set up the next one. We're going to make the next slide long, and then I'm going to run through it again and see if you can understand what's going on. Understood? Are we good? Okay, take 3. We did a little board work. Amir's being very facetious today. What a great smile. Excellent, excellent smile. Okay, now, so at every second, we're going to find out what the height is off the ground, correct? we know from the problem that we just did, this is the same problem, that the height is going to be 500, right? 500 meters, correct? We know that. Now, we want to see the sequence of events as it unfolds from 0 to 10 seconds. What is going to be the initial velocity at every second? 100 meters per second, correct? Okay. So it's going to be v naught t, which is 100 meters per second, times, at the first second be 1, and then plus 1/2 negative 10 times whatever the second was. So the first second would be v naught would be 100 times t plus 1/2 negative 10 times 1 squared. So you could simplify it and say 100 times 1 minus 5 times 1 squared. Where did I get minus? Well, minus because it's negative, you're going up, and 5 because it's half of 10. Correct? So 100 times 1 is what? 100 minus 5 times 1 squared is what? 5 times 1 squared is what? 5. So 100 minus 5 is 95. All right, right now, figure out the second. Right now, everybody, go on. What's the second? 185? 180? All right, well, that's first one's 95. What's the second one? 180. What's the next one? 255. All right, try to do the 6th second. Eustace, do the 6th second. Okay, do the 6th second. $480. Sorry, 420. 455. Getting close. 480. And then what? 495. And then 500. And now what we're going to do is we're going to look on how to do the problem going down. How to do the problem going down. Well, what would you say? You can see that it's going to be the height, 500. What's the initial velocity? What is the initial velocity on every second between second 11 and 20? What's the initial velocity? No, what's the initial velocity? At D max, what's the velocity? Come on, guys. At D max, it's 0 is the initial velocity, correct? 0. So what's the height? 500, correct? So it'll be 500 minus whatever what? Whatever distance you went. So the first one would be 500 minus 5 is 495. What's the next one going to be? Minus 20, which is 480. Then what is 5 times 3 squared? 45. What is it? Okay. You see how it's going down? You see? See the sequence of events? Yes? Okay. And then what we'll do is when we get down near the bottom, I'll stop it and change the time frame, and we'll see what happens. Everybody clear on this? Pretty good? Yes? Okay. Very good. Excelente. Excelente. All right. Now the next one should slow down. Okay, that's going to be a longer one. All right. And what we'll do is we will check to see where we are. All right. So we have quite a few seconds left for the last one. Okay. So that's going to be 0. Notice how symmetrical this is. Now this is perfect conditions though, isn't it? No air resistance. What goes up comes down, and we have to ignore what? We have to ignore air friction. We have to ignore the fact that it's on Earth and etc. So we start with no friction. when we do straight line motion. We do it as if there's no friction. And then when we do Newton's laws, we're talking about friction. Okay? So let me set up the next one. I'm going to put this on stop, and we'll set up the next one. Clear? And we'll see if we can't do this. You can see what's going on with the next one as it is. Okay, welcome back. Now, what we're going to do is we're going to look at the last problem we did where the rocket was fired at an initial velocity of 100 meters per second. It climbed to 500 meters and then fell back to Earth. We're going to look at the sequence of events whereby it reached Dmax, or 500 meters. Again, the initial velocity was 100 meters. But what I want to show here is how the distances are measured second by second and how the instantaneous velocity is determined second by second. You can see that the distance equation reduces to d equals v naught t minus 5t squared. Minus because g is minus because it's going up, and 5 because 1/2 of g is 5. So v naught t minus 5t squared, and then it would be v naught minus gt. Okay, now, if each one has a 0 at t equals 0, the d would be 0, and at t0 for velocity, it would be 100. So what we're going to do is we're going to go just 7 seconds per slide and see if we can determine the distance and the velocity each second. Make sure you follow along and try to do it yourself. You can put this on pause, rewind it, but it's very important that you see the pattern, you see the sequence. You see that the seconds are linear, going up, it's all the same, 1 second, 2 seconds, 3 seconds, but the distance is not linear, it's actually parabolic. So it's not, it's going up large amounts at first and then smaller amounts as you go higher and higher. So we see that the change in distance is going to be 95, 180, 255, 320, 375, and you can plug into the equation and try to guess. And then the velocity is going to deaccelerate at the rate of 5 meters per second each second. So at the end of every second, succeeding second, the velocity will be 10 meters per second less. And that's exactly what's happening. So we're getting near the end. How well did you predict each particular second and the changes in distance and final velocity? Okay, now, so we're at the last second, and that one's going to be, what do you think? Yeah, 500 and 0 velocity. Now, we'll take some time doing this frame, and then we will allow you to do them more quickly, because you should be, between lecture 2 and 3 for linear motion, you should be pretty good with this by this time. So now we have an initial velocity of 500 meters. Use the same techniques that we've been using and see if you can't do this correctly. Okay, be right back. Okay, 3 seconds per slide. Put it on pause if you need to. So that's 50 seconds. What's Dmax going to be? Okay, 12,500 meters. What is going to be Vy at Dmax? Well, it's going to be 0. What's going to be G at dy, or G at Dmax? Well, it'll be 10 meters per second squared. And then what about at 78 seconds? So after it's fallen 28 seconds, 28 times 10 is 280. Negative because it indicates direction down. And then the height, and then the final would be that. Okay, have a great day. Hope it was beneficial. Have a good day, and goodbye. Oh, by the way, just going back just for a second, V final, because V final, in other words, it starts at 500, goes up, and then comes down. And if there's no friction, the up and the down, it's going to be symmetrical. So it starts at 500, goes to 0, falls for 50 seconds, and picks up a speed of 500 meters per second. It's not the way it works in light because of air friction, terminal velocity, etc. But based on what we're doing right now, that is actually the case. Have a great day, and goodbye.